All right, so we've learned what a polyhedron is, how to tell the difference between the polyhedron and not a polyhedron as far as solids go. And we're going to turn our attention to surface area of these solids, some polyhedrons, some not. Okay, so we need to be able to find the surface area of a prism, cylinder, pyramid, and cone before this is all done. Some quick vocabulary for you. We've already talked about prisms, so I feel comfortable that you know what a prism is, but the definition of a prism, the geometric definition of a prism, is a polyhedron with two congruent faces called bases that are parallel. So the bases that are parallel and congruent are going to be your bases. And so in this octagonal prism over here to the right, your two octagons are going to be your bases. Okay? Next, the rectangles here on this side are called lateral faces. Lateral meaning side, so hopefully that makes sense. The where two lateral faces meet are called lateral edges. Okay, lateral faces, lateral edges, those are going to be kind of important to us in just a few moments. Some more. The surface area, there's two thought processes for finding the surface area. One is to simply find the surface area of all of the faces and add them together. Find the area of all the faces and add them all together. Surface area, what we're talking about is trying to cover this pentagonal prism in paper, right? So I have to cover all of these faces, including the bases, and then start working on covering the lateral faces. So we can do those individually and add them all up. I think that makes enough sense. Okay? The lateral area, that would be the total surface area. The lateral area is just the area of the lateral faces. So these rectangles. Okay? Again, lateral meaning side. So to see this, to try to help visualize the surface area of a solid, sometimes it's helpful to cut these solids down into what's called a net, right? Cut at some of the edges and be able to lay it down flat to make it two-dimensional. Then we can kind of see why it makes sense to find the surface area the way that we do sometimes. Okay? So, what we mean by a net, I'll show you in just a second. Okay? All right, prisms first. There are two types of prisms. There are right prisms and there are oblique prisms. So again, some more definition. A right prism is when the lateral faces are perpendicular to the bases. Okay? An oblique is what happens when the bases sort of shift in opposite directions, and now the lateral faces have to reach to get to the bases. So they're not going to be perpendicular anymore. We're going to focus primarily on right prisms and not so much on oblique prisms. Okay? All right. Finding surface area. And so the first way to think about this is, like I said, to find the area of each face and add them all up. And here's why that makes sense. If we have a rectangular prism that has a height of 2, a length of 5, and a width of 6, then what you can do is you can take this prism and imagine cutting it along some of the edges. So along here, 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 and here. And then laying it down. And that's what this is showing you to get to this. Okay? If we do that, then we need to notice some things. First off, the height, right, is going to be represented by this side, this side, this side, this, and this, right? And so you get, when we lay it down, these are your sides. I'm sorry, those are your heights of the prism. So they're going to be 2 centimeters. If you watch how this unfolds, the width, which is 6, is here, 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 and here, which as you watch this unfold becomes this length, this length, this length, this length, and this length. So when you lay it down flat, it becomes this, 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 and this. So those are all 6. Okay? Now, the length, which is represented by this, 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 and this in the solid, as you watch this unfold, becomes this, 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 here, here, and here. And as you lay it down flat, becomes this piece, these pieces, and those pieces. And those are all going to be 5 centimeters. So, to find the surface area, we can lay this thing down and then just find the area of all of the different panels, all the different faces. Where this is going to be 5, 5, 5, 6, 6, right? Let's see, that might be all we need. So to find this, to find the top rectangle, 5 times 2 is 10. Right? And then to find this rectangle, 6 times 2 is 12. To find this one, again, 5 times 2 is 10. To find this one, 6 times 5 is 30. And then to find this one, 6 times 2 is 12. And then inside of here, 6 times 5 is 30. So what you find is to find the surface area, we've got 2 10s, so 2 times 10. We've got 2 12s. We've got 2 30s. And we can add all those up and we get 104 centimeters squared. Okay, easy enough. There's a lot of work. I mean, as we add faces to our prism, it just becomes more and more pieces that we have to find areas of and add them together. So ideally, we'd find an easier way to do this. And in fact, there is. Okay? If I want to find the surface area of this right pentagonal prism, okay, then I would have basically 7 faces that I have to find the area of now. And then add all those up. What I can do instead is develop a little bit more of a more direct formula. Okay? Here's how I'm going to do that. We can consider in this rectangular prism that this and this are the bases. Now, there are a lot of different options for the bases, but just for right now, those are the bases. The bases are parallel and congruent. So the fact that these 2 areas were both 10 should not have been a surprise. Okay? So if we find the area of one base, we find the area of the other one. In other words, all I have to do is find the area of one base and multiply it by 2. That's where we start here. We find the area of one base, and since there's 2 of them, we can multiply that area by 2, because the bases are going to be the same. Then we need to find the lateral area. Right? So here's the base, here's a base. The lateral area needs to be added in. In other words, the area of all the sides added together. So I've got to add in. Well, how would we find the lateral area? Yes, I could find the area of 5 rectangles and add them together. But if I look, I come back here to this net and pay attention to as we go backwards, you can kind of see that this rectangle, which is one giant rectangle, which we could have found the area of and added in to our 2 base areas from the last example and been a little bit quicker. But to find the area of this rectangle, you would take the length times the width, right? Where the width is 6, and the length goes all the way across here, right? But if you look, this length is also right here, which if we follow it back even more, is this length right here. Well, this is just the perimeter of the base. So to find the area of this giant rectangle, I would basically take the perimeter of the base and multiply it by the width, which is this 6, which is going to be the height, right, of the prism. So here's what I mean with the pentagonal prism. So what that means is, and since these guys I said before are our bases, we got to find the perimeter of the base and multiply it by the 6, which becomes this, which is really the height of that prism. So to add in the lateral area, to find the lateral area, I would simply find the perimeter of our base and multiply it by the height of the prism, h. A little bit quicker formula to get there. So I need the area of this pentagon. It's a regular pentagon. So I'm going to take 2 times 1/2 ASN. That's how we find the area of a regular pentagon. Add into it the perimeter of that pentagon times the height of the prism. Okay? Now 2 times the 1/2 ASN because there's 2 bases. So we can start filling in some numbers here. 2 times 1/2. We need the apothem, which we don't have. So I'll leave that blank for a second. The side length is 7.05, and it's got 5 sides. That's n. Plus, well, the perimeter is going to be, the perimeter of that pentagon is going to be the side length times the number of sides, and then we're going to multiply by the height of the prism. That's where the 9 comes in. So all we need now is the apothem for that pentagon. Well, we have to go back to chapter 11 stuff, and remember that the apothem is here, and if we draw in a radius, then we create a right triangle, which I'll redraw over here. We need the apothem. That radius we don't know. This piece down here, this side is 7, so this part down here, 7.05. So this part down here is half of that. Remember that in the right triangle, it's half of that, or 3.525. Okay. Oh, actually, we do have the radius here, which is 6. So to find the apothem, we can just do Pythagorean theorem, where 6 is the hypotenuse, and A and 3.525 are the legs. We solve this down, and we discover that the apothem is about 4.9 or so. Okay, and I'll let you do the arithmetic on that. So this is 4.9. And then it's just a calculator from here. You're just multiplying all of these together. So we would take 2 times 1/2, which is just going to multiply to 1. So 1 times 4.9 times 7.05 times 5 plus 7.05 times 5 times 9. And if you were to do that, you would get about 488.57 feet squared. Okay? So hopefully that makes enough sense. The bottom line is, what I'm going to continue to talk to you about is, well, first of all, yes, we can find the area of each face and add them all up. Or we can go quicker with this formula. Find the area of a base, multiply it by 2, and then take the perimeter of the base and multiply it by the height of the prism, which will give us our lateral area, and then add those 2 together. Okay? And we can apply the same thought process to cylinders, right? So here, in this example, we're going to take CDs, 20 of them. So here's the CD, and if we stack 20 of them, we would basically get a cylinder. Okay? Now, it says here that the height of a cylinder is 1.2. All right, I lost my train of thought. So anyway, the height of each CD is 1.2 millimeters. There's 20 of them, so the height of the cylinder is just going to be 1.2 times 20, which gets us 24 millimeters. And we see there that the radius of the CD is 60 millimeters. Okay, so we want to wrap this in shrink wrap. So basically find the surface area to know how much shrink wrap we need. Well, the thought process is the same. We're going to have to cover the bases. The bases are going to be, again, those congruent parallel faces, so there's the two bases are going to be the same. So we find the area of one base and multiply it by 2, and we'll have the area of both. And then we got to find the lateral area, which is, just like last time, find the perimeter of the base, so go around the cylinder, and then multiply it by the height of the cylinder to wrap it down the side, to wrap up down the side. Okay? The only difference here is, what shape are the bases in? They're not pentagons now, they're circles. So we would take 2 times, the area of a circle is pi r squared, add into it the perimeter of the circle, but we don't call it the perimeter, we call it the circumference, so 2 pi r, and then multiply it by the height h. And now, we just plug in what we know. R is 60. And then the height of this cylinder, like we said, is 24. Okay, 60 squared is 3,600 times 2 is 7,200 pi. Plus 2 times 60 is 120. Well, actually, it might be, well, yes, this is going to end up being 2880 pi. And then we add this, we get 10,080 pi. I'll let you multiply that out. This is going to be millimeters squared. Multiply that out and round it. Okay, now I'll tell you the minimum amount of shrink wrap needed to cover that cylinder. Okay? So we're going to keep doing this process of finding the area of the bases and add it to the lateral area, the area of the side. Okay? Now, we could use this to work backwards and find the height of a prism or find the height of a cylinder if we wanted to. Like in this example here. We have the surface area. We want to find the height of this guy. Well, again, I'm going to start with the thought process of the surface area of find the area of the base, multiply it by 2 because there's 2 of them. Find the perimeter of the base and multiply it by the height of the cylinder to get that lateral area. Right? So, area of the base here, again, it's a circle, so pi r squared. The perimeter of the base, 2 pi r times h. And we know the surface area is 157.08. And now we start filling in what we know. We know the radius here is 2.5. Right? So 2 times pi times 2.5 squared, then 2 times pi times 2.5. Times the h. And we got to go solve for the h. So we've got to multiply 2 times pi times 2.5 squared, and I'll do this for you real quick. So we get 39.27 plus 2 times pi times 2.5, 15.71 h, and then it's a simple equation to go solve. And so h should be about 7.5 meters. Okay? All right. I'm going to stop this video here and I have to create another one. So look for that second part to come right behind this one.